All right, for this bell work, I got my Y-Intercept. I'll start with that because that's the first thing I can put on this graph. And I know, again, it's not 3 right here. It's actually 0, -3, okay? So 0, -3, I found it on the graph. Just go from the origin, go 3 units down. Boom, I found it right there, 0, -3. And then I know that the coefficient of x is the slope. So my slope here is just showing as 3, but I can force 3 to become a fraction as 3/1. And that's rise over run, right? So I know my numerator is the rise, and it's positive, so I'm going to have to go up. My denominator is the run, so I'm going to have to go to the right one since that's positive as well. But it's from that point that I already put on the graph, the Y-intercept, 0, -3. So from there I go up 3 to the right 1, up 3 to the right 1. And that tells me where my next point is. Now that's a stair step though, so I'm going to copy that stair step, up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. And that tells me where the line is. But I can copy this backwards by going left 1 down 3 as well. Left 1 down 3, and that gives me my line. So now that I've got all the ordered pairs, what I now need is the actual line. So let's get that on there. I'll use some technology, otherwise it looks like garbage. But that's good enough. I'll just put some arrows on the end, and that's good. Oh, now, the last thing I'll mention here is that all these other ordered pairs, remember we've done this before, but like this point right here, what is that, 3, 6? So if you went in and replaced the x with 3 and the y with 6, you would get a true statement right there. But that's true for all the other ordered pairs as well, like this one right here at -1, -6. So again, if you replace the x with -1, the y with -6, the equal sign becomes a true statement. That's true for all the ordered pairs on the line, including the in-between ones that are fractions. So there's our 2 objectives for the day. I can find the slope and parallel and perpendicular lines. And then I can graph lines that are parallel and perpendicular to each other. So just kind of a quick reminder of parallel lines. So parallel lines, they never intersect, okay? They never touch, they never intersect, they never come together, however you want to say that. And then perpendicular, that tells us that the 2 lines will create a 90-degree angle with each other. Okay, so if you look at examples, let's look at parallel lines first, right? So if you look at this line right here, and let's pretend like I've drawn that real well. It's decent, but not great. But let's say that this blue line and the red line are parallel. Since we're talking about slope, there's something that you should notice about the steepness. Again, assuming that I had drawn those better. And then for perpendicular lines, usually you got, I don't know, something like this. Something like this. And then perpendicular, again, it's going to create some kind of 90-degree angle with that. Again, we'll assume that I've drawn something real nice, but again, it won't put that mark there like I've done, but in the past, hopefully you've seen that mark as a 90-degree angle. It means the same thing. Okay, but again, think about how this would relate to the slopes, because that's what we're going to be looking at. And then once we get those slopes, it should be pretty easy to graph those lines. So we definitely want to be able to do these 2 objectives by the end of the lesson. If you can't, then you need to be asking questions. So to start out here, we got parallel lines. Now it says that their Y-intercepts are different. The only reason why that's important is that it makes them different lines. Because think about this, with parallel lines, we are expecting the slopes to be the same, right? So let's say that I create this line right here. Yeah, that's good. Something like this, okay? So I can see my Y-intercept there at 0, 6. Okay, but it says that the parallel lines, their slopes have to be the same, okay? So we look at this line and we say, well, what is the slope? Well, if it's going through these 2 points right here, I can see that I'd have to go up 4, and then to the right, looks like to the right 7. Okay, so that would give this line a slope of up 4 to the right 7. That's 4/7 slope. So if I were to create a parallel line, I would have to get something as well that would be that would have a slope of 4/7. Okay, so I can give myself some other line like this one. Let's see if I can do this right. Something like this. Okay, so now I would be using this point and this one. But again, it shows that it goes up 4 and then to the right 7. So the slopes end up being exactly the same here, which they need to be for parallel lines. But again, what does that mean about the y-intercepts? Well, they're different, right? This one has a y-intercept of 0.6. This one has a y-intercept of 0 and negative 6 point something. Okay? As long as they're different, then we know we have different lines. If by chance we have the same y-intercept with the same slope, then it'd be like drawing this red line and then drawing a purple line directly over it. It's just the same line, okay? But again, we need the slopes to be the same for these parallel lines. And we know that because essentially with parallel lines, the steepness is the same. So the slope is the same. So again, that may be redundant because steepness is slope. But it doesn't matter if it has a positive slope like these two do, or if they're negative, or even if they're straight vertical lines or straight horizontal lines like this. So what they're going to do on some of the problems later is they're going to give you one of these lines, and then you got to graph another one. It doesn't matter where you put it. Again, for a parallel line, you would just expect the slope to be the same. So what is the slope of a line parallel? So we're looking at parallel here to the line whose equation is x minus 2y equals 4. Well, we know that the parallel lines have the same slope. So whatever slope we get out of this, we know that we're going to have the same slope. Okay, so let's go ahead and see if we can change this into slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, well, to do that, like we've done before in previous lessons, I got x minus 2y equals 4. Let's go ahead and change that in slope-intercept form. And the first thing I'm going to need to do that is to get rid of that x. Now it's x minus 2y equals 4, so I'm going to have to subtract x from both sides. Now I'm offsetting the 4 and the minus x right there on purpose because I can't combine them. They're not like terms. So that zeroes out the x's. I can now drop my negative 2y's because they are by themselves with the 0. And just like I've done before, I'm going to switch these two terms. I've got a negative x and a positive 4. Why did I do that? It's because it's now in that same format, y equals mx plus b. You can make it 4 minus x if you want. It just kind of changes the order. That can cause some confusion. Now, the last thing I want here is it to be y equals mx plus b, right? That's a phantom 1 coefficient of y, not a negative 2 coefficient of y. So, to make that negative 2 a phantom 1, I got to divide it by itself. But if I do it there, I got to do it everywhere. So I'm going to divide by negative 2. I can see negative 2 divided by negative 2 is 1. So, there's my 1. And it's right there. The 1 is just a phantom 1. Now the negative x I'm going to show as negative 1x. So what's my coefficient of x now? Well, negative 1 divided by negative 2 is positive 1/2. That's my slope. And even though we don't need it, my y-intercept is still easy to find. 4 divided by negative 2 is negative 2. So I have my slope and my y-intercept. I could graph that equation if I wanted to. Of course, no one really ever wants to do math. But in any case, I now have my slope, right? So the parallel slope is going to be exactly the same. So where I found my slope here as 1/2, the parallel slope will be exactly the same as 1/2. And that's it. So this one, again, we want the slope of the parallel line from this equation. That's great. And we know that parallel lines have exactly the same slope. Okay, so whatever we find for the slope here, the parallel slope will just be the same as that slope. Okay, so we want this to be in the form y equals mx plus b, where m is the slope and b is the y-intercept. But the equation that's given here is not in slope-intercept form. So just like the last problem, we're going to have to change that into slope-intercept form with some principles of equality. So I got 8x minus 6y equals negative 24. I don't want the 8x with my negative 6y's, so I'm going to have to zero that out by subtracting negative 8x from both sides. So that will zero that out, which then allows me to drop, it's not 6y, it's negative 6y, equals, again, I'm going to change the order, negative 8x and a negative 24. Please do not combine those because they're not like terms that you can combine them. Last thing I want here is the coefficient of y to be a phantom 1, not a -6. So I'm going to take that -6 and divide it by itself. But if I do it to one side, I got to do it to all the terms. Okay, so that becomes a phantom 1. -8 divided by -6 simplifies into 4/3 positive. And then even though we don't need the y-intercept, I'm still going to solve it. -24 divided by -6 is +4. So we would have a y-intercept at 0,4, but we don't care about that because we just want to know the slope of the parallel line. So I want my parallel slope, which is just a match of my slope from this equation. The slope is always the coefficient of x. Here I got a +4/3. Now if we were to graph that, that would be up 4 to the right 3, just because that's always rise over run, just as a quick review. But that's it. We got our slope. That's good. This brings us to perpendicular slopes. So two things on this one. You have opposites. That's talking about the sign on these. So when we're talking about the sign as well, that's either going to be positive or negative signs, okay? So slopes for perpendicular lines are going to have opposite signs. If you start with a positive, perpendicular slope will be negative. If you start with a negative, perpendicular slope will be positive. Reciprocals, though, that's where we flip the fractions. So that's all the reciprocal is. Okay. So we've seen reciprocals before, but let's just give ourselves a couple examples here, right? So again, we'd be looking for perpendicular slope on these. So if I started with something like, let's say, I don't know, 2/5, like this. Then if I wanted the perpendicular slope, I would need the opposite reciprocal. So I guess I'll start with the opposite. The opposite, since this fraction that I've started with is positive, I would need a negative fraction here, and then all I gotta do is flip the fraction. So where I have 5 in the denominator originally, it will now be in the numerator. Where 2 was in the numerator, it is now in the denominator. This is my perpendicular slope right there, okay? Now, what you may see from time to time is you may see just a regular number, let's say like -8, like this. Okay, now since we want the opposite reciprocal here, what you'll probably want to do is make it a fraction, which we've done before, okay? So we make it -8 over 1, and from here, we know that since it's negative, I'm going to make my new fraction positive, but then just flip the fraction into 1 over 8. So where this one is down 8 to the right 1, this one's up 1 to the right 8, which gives us perpendicular slopes. So if I were to demonstrate, for example, 2, 5, again, you'd probably start with some kind of graph, which sometimes they give you the points, right? So we'll start here. We'll make this one red. So if I start with this point, it would be up to the right 5, about right here. And then they'd give us a line. Something like this. Okay, now since the perpendicular slope is the opposite reciprocal, we know it's -5 over 2. So again, it doesn't matter where you start. I'm just going to choose a random spot to start, let's say right here. So again, I'd go down 5 and then to the right 2, which would give me this point. And yeah, if I really wanted to be thorough here, I could put the rest of the points on here, but it doesn't matter. And then I can graph the line. Like this. Now I didn't draw that very well, but this is good enough to see, hopefully, that we have a 90-degree angle right there, which is what makes a line perpendicular, okay? So the slopes are opposite reciprocals, and then once you have done that, you will have found the slope of a perpendicular line. So the y-intercepts on these ones, notice it doesn't say anything about the y-intercepts here. It's only talking about the slope, because we don't care if the y-intercepts match for, or don't match for perpendicular lines. Really, that's only for us parallel lines. So for this example, again, it hasn't given us the slope directly, right? So what we need to do is change this into slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. So yeah, this one, even though we don't care about the y-intercept, we're still going to find it just for good practice on this. So to change this into slope-intercept form, y equals mx plus b, I'd like to first isolate my 15y's, so I got to get rid of that 6x. So minus 6x from both sides. Okay, that will zero that out. Then I can drop my positive 15y, which now equals, though, again, I'm going to switch the order here so it looks like slope-intercept form. Negative 6x first and then positive 225. Please do not combine those because they are not like terms that you can combine. Last thing I want here is to make the coefficient of y a phantom 1. So to do that, I'm going to divide itself, the coefficient of y, 15 by 15. But if I do it there, I got to do it everywhere. Okay, so that becomes a phantom 1. Now my coefficient of x, negative 6 divided by 15, gives me negative 2/5. All right, so that'd be down 2 to the right 5. And then my y-intercept, 225 divided by 15 is positive 15. So I have my y-intercept, even though we don't need it. But what I really want here is my perpendicular slope, which is going to be the opposite reciprocal. So where our original slope right now is at negative 2/5, the opposite of that would be positive, and you can put a positive sign if you want, just don't put it in the assignment. Then I'm going to flip that fraction into now 5/2, okay? So my perpendicular slope right here, positive 5/2, which again would be up 5 to the right 2 if we were to put this on a graph, which we will, but not yet. This one is going to work exactly the same. What we want first, since this is not in slope-intercept form, is to change it into slope-intercept form, which is y equals mx plus b. All right, so we know that m is the slope, b is the y-intercept, and we'll use some principles of equality to do this. All right, so the 3x, again, I don't want that there. What I'd like to do is be able to take that negative 3y and just drop it by itself. So I don't want that 3x, so I got to subtract 3x, not just from the left, but from the right as well. That's a principle of equality. That will zero that out. Now, what I have is negative 3y equals, again, I'm going to switch the order, negative 3x and positive 63. Okay, so these two, again, please don't combine that x term with the constant 63. But the last thing I want here is the coefficient of y to become phantom 1. So I'm going to take that negative 3 coefficient of y and divide it by itself, negative 3. But if I do it there, I got to do it everywhere. So that becomes a phantom 1. My coefficient of x now is negative 3 divided by negative 3, which is 1. And even though you can make that a phantom 1, I want to see it. And then 63 divided by negative 3 would be negative 21. So we have the y-intercept even though we don't need it. Again, that's just some good practice. So what we want now, again, is the perpendicular slope, which is going to be the opposite reciprocal. Okay, so the slope that I have right now, showing it's 1 right there. So if I put my slope in as 1, what I'd like to see is this as a fraction, right? So I can flip it. Now that's 1/1. This, by the way, is positive 1/1. So my opposite reciprocal slope, it will be negative, and then I flip the fraction into 1/1. Really what I'm going to do is just 1/1 is just 1. So to make that look pretty, I'm just going to make it negative 1. And that, right there, that would be my perpendicular slope. So it does come out as a whole number, which is not so common, but it happens. It's just a negative 1, okay? So, again, we've seen parallel lines will have the same slope, exactly the same slope. It says they're equal, it's the same thing. But the y-intercepts should be different. If they're the same y-intercepts, it's just the same line, which we don't really want to see yet. And then perpendicular lines have opposite reciprocals. And just like we saw in those last few examples, opposite is talking about the sign being either positive or negative. And then reciprocal just tells us to flip the fraction. So for this graph right here, it says graph a line that is parallel to the given line. Determine the slope of the given line and the one you graphed in simplest form. So if we have fractions, we'll simplify it. Click and drag on the graph to draw a line. So we're looking at some kind of parallel line right here. Now you can graph first if you'd like. You can find the slope first if you'd like. Doesn't really matter. For this one, I'm going to use the slope formula though. Now, do you have to use the slope formula? You do not. Some students prefer to just use the graph for the slope, and that's fine. Now, since we're used to finding the y-intercept first, I'm going to find it. I found it, 0, -8, okay? Now, that is an x and y value. We know for the slope formula, the y's go on the top, and then the x's go on the bottom, right? So for this ordered pair where x is 0, it goes on the bottom. The y is -8, it goes on the top. So I've got that one ordered pair. We just need any other ordered pair on the graph. Doesn't matter which one you choose. I'm I'm going to choose this one just because I can, which is at 10, -8. Okay, so again, I've got an x and y value. The x is 10, it needs to go on the bottom of that slope formula, and then the -8 is the y, it has to go on the top. Now, when you put this in the calculator, again, make sure you put parentheses around the numerators and denominator like this, but when you do, you're just going to get a 0 slope. So that means the original slope is 0, so the parallel slope should also be 0. And it's okay for them to be 0, but now that I've done that, I just need any line that's horizontal, because this one's a straight horizontal line, anywhere on the graph. So, again, it doesn't really matter where you put it. I guess, what the heck, I'll just put it here. So, put some arrows on that, call it good. On the assignment, I think you just got to click on 2 points. Any 2 points that would make this a horizontal line, you're good. But again, I put it here. It doesn't matter if you put it there. It doesn't matter. You can put it below if you want. It just needs to be parallel to this one, so the slope needs to be the same. Now, I know it didn't ask for this, but if it wanted a perpendicular slope, you'd have to look at this as 0 over looks like -10, right? Well, you could flip that to make it -10 over 0, which would just be undefined in that case. So again, that's a hypothetical, but your perpendicular slope would be undefined. We didn't need it, but again, it's just a quick review there. This one also, we want a parallel line to this one. So yeah, we do need the slope. Whether they ask for it or not, we definitely need that slope right there. Now again, I can find my y-intercept right here at 0.8. Again, the reason why I need that is because I am now going to use the slope formula on this one. Okay, now it's always subtraction between the values, but it should be y's on the top, x's on the bottom. So right here, I have an x and a y value from my ordered pair of 0, 8. So the 0 on the bottom, 8 on the top. Now there's several ordered pairs you can use. I'm going to use this one right here, because again, I can. And that looks to be at 6, 10. So I have an x value that's 6, and then the y value is 10. X is on the bottom, y is on the top. 6, 10. Now I used that point, but some of you noticed that there were plenty of other points you could have used. You could have used this one at -3, 7, or this one, or even if you wanted to, this one right here, okay? I just happen to use the green one, but it doesn't matter which other one you choose to find your slope, okay? But when I put this in the calculator, again, I'm gonna put some parentheses around these and see what we get. And my calculator says your slope is 0.3 repeating. Well, I don't want that decimal, so I'm going to push math, enter on the calculator that I have, and it says, oh, you wanted the fraction? Fraction is 1/3. Okay, so that would be up 1 and then to the right 3 for the slope. And so if you wanted to, some of you noticed you could have used the graph for that. So this would have been up 1 and then to the right 3 as well. So if you want to use the graph, that's fine. If you want to use the formula, that's fine. But the original slope here is 1/3, which means the parallel slope also needs to be 1/3. Okay, so again, it doesn't matter where I put this line, just anywhere else other than where the line is currently. So I choose, again, I'll just choose a different y-intercept, 0, -6. From there, I'd have to go up 1 and then to the right 3. So that would give me that point. Again, since I'm doing it by hand, I guess you could put these other points on here as well. Not that you have to, but you can. Something like this. And now that I got that, I'm ready to draw the graph. Something like this. So yeah, now that I've got that, I've got two lines that are parallel. Again, I put my line right here. On the assignment, it doesn't really matter where you put it, just anywhere else other than this line. And then again, just as a quick review, if it wanted the perpendicular slope, we would have had to make that the opposite. So it would have been a negative and then flip the fraction 3/1, which would simplify to -3. But I also assume you don't care. So for this one, we want the line that's perpendicular to the one that's given, and then we'll find the perpendicular slope. So we do need the original slope on this one. Then we'll also graph it, right? So now to start out on this one, I don't have a y-intercept, but I do have an x-intercept right there at -2, 0. And then again, any other ordered pair will do for this. So I don't know, I'll choose this one at -2, 5. Okay, so what I would like here is my slope. So I'm going to use my slope formula. It's always subtraction of the y's and x's. Y's on top, x's on the bottom. And I have my two ordered pairs. I've got my first one in green at -2, 0. So -2 on the bottom, 0 on the top. And then my orange ordered pair where -2 is on the bottom because that's the x. And then the 5 is the y goes on the top. Okay, so I'm going to put this in the calculator with parentheses around there, the numerators and denominator, and then we'll see what we get. And yeah, on the calculator it says error. It's an error. It says it's a divide by 0 error. What that tells us then is that the denominator, if you were to evaluate this, the denominator would have been 0, and in this case, just the numbers that I'm using, the numerator would have been -5. You can't have a 0 denominator. Since it is an error, we're looking at something that is undefined. Okay, but that's our original slope right there, okay? Undefined, you would not put -5 over 0 right here, okay? Just click undefined and then that would be good. But what we want now is the perpendicular slope. Well, my current slope right now as a fraction was -5 over 0, which does produce an error. What I want then is the opposite reciprocal. So my opposite reciprocal, it's a -5, so that's going to now be a positive fraction. It's not going to matter because it's 0 over 5, which really just comes out to 0. So my perpendicular slope here is 0. Okay, well, 0 tells me that a 0 slope tells me that I got a flat line. So anywhere on the graph, I just need to put some kind of flat line. Doesn't matter where it is. Anywhere will do. I guess right here is good. Again, I put it right there. Doesn't matter where you put it on the assignment. It does not. Just anywhere. And now we can even see clearly a right angle between these two lines. It's 90-degree angle. Okay, then again, just a quick reminder, if it asked for a parallel slope on this one, it would have just been another undefined slope. Okay, so this one I can actually see the slope. It has slope, it has steepness, that's good. And we'll find that as the original slope. Since I am looking for slope on a line, I'm gonna look for my slope formula. But if you wanted to use the graph, you could, which we will show. So it's always subtraction, y is on the top, x is on the bottom. My first ordered pair, again, I'll just use my y-intercept here at 0, -7, though you don't have to. There's lots of other ordered pairs you could have used. And then the other one I'm going to be using, we got to go through this graph. We want to see where it goes exactly through one of the grid corners because it's an exact location. If you can't find one that goes through a corner, you're not looking hard enough. The reason why we want that is because we don't want fractional values here. So the one I'm going to use, this one right here, which is at -2, -4. But again, there were plenty of other ordered pairs you could use, like this one, or this one, or this one, or this one, or even this one. So the orange ordered pairs would work. Doesn't matter if you use those or not, you're still going to get the same slope. So with the purple ordered pair, the y-intercept, I have an x that's 0, that goes on the bottom. The y value is -7, has to go on the top. For my green ordered pair, the x is -2, so that goes on the bottom. And then the -4 is the y that goes on the top. So now that I got that, I'm ready to put this into the calculator. Okay, so what am I going to get from this? Let's put it in there. Parentheses around the numerators and denominators, though. So yeah, when I put this in the calculator, I got -1.5. I don't want that decimal, though, so I'm going to push math, enter, and it says, oh, you wanted the fraction, huh? So that's -3 over 2. So my original slope here is -3 over 2, which again would be down 3 and then to the right 2. Okay, and you can see that in the graph from any 2 points, like this 2 right here, you'd go down 3 and then to the right 2. If by chance you miss those 2, let's say you went down 6 and to the right 4, it still simplifies into down 3 to the right 2. Okay, but we want the perpendicular slope, right? So what I need here is I'm going to take my my slope, which is showing as the current slope, -3 over 2. My perpendicular slope is going to be the opposite reciprocal. So the fraction I'm given right now is -3/2. So my perpendicular slope will be positive. And again, I'm going to show the positive sign, although you don't necessarily have to. And then flip the fraction into 2/3. So it's positive 2/3 right there. That's my slope for my perpendicular line. So again, I just type it in as 2/3 right here. Well, that's nice, but now we still got to graph the line, right? So again, it doesn't matter where you put it. If you wanted to, for some reason, you can start at like a point on the graph. Like if you wanted to, you could start right here if you wanted. And then you just go, it was up to, and then to the right 3. Okay, and that would give me this point. And again, I can continue that pattern up to the right 3, up to the right 3, up to the right 3, or left 3 down 2, left 3 down 2. Okay, so that's just showing all the points. Any of the points you could have used if you wanted to. You get something like this. So again, that's not drawn super great, but we now know that this would have been a 90-degree angle between the two lines. And that's what perpendicular means, okay? There's our 2 objectives. Hopefully you feel pretty comfortable with these. I can find the slope of parallel and perpendicular lines. Once we find those slopes, we should be able to graph any line that's parallel or perpendicular to the one that's given on those graphs.